Hi everyone, in this video we are going to solve a problem. The problem name is convert sorted list to binary search tree and the problem number is 109. Alright, so guys, first of all we are going to clearly understand what this problem says. After that we are going to move to the logic part and after that we are going to implement our logic in C++, Java and Python programming language. Fine, now let's see what this problem says. So this problem says given the head of a single linked list, so we are given with the head of a single linked list where elements are sorted in ascending order. That means our single linked list in a sorted order in ascending order, right? Convert it to a height balance by necessity. Now this singly linked list we have to convert in a height balance by necessity. So we are given the first thing we know that we are given with the head of a singly linked list. Like let's understand this statement with this example one, right? So let me scroll it down. So guys, this is nothing what we are given with. We are given the singly linked list, fine, and you can see that this is nothing but in a sorted order, isn't it? Now what we have to do? We have to convert this singly linked list to height balance by necessity, right? I hope this making a sense, right? Now, what is height balance by necessity? If you know, then well and good. If you don't know, then let me tell you height balance by necessity. What is this? So, guys, a binary necessity, you know that left part should be the smaller, right part should be the greater from the root, right? But height balance by necessity, it says that, let me write binary and search and tree, right? So, it says that the left height of left subtree, let me write height of left subtree minus height of right subtree, height of right subtree should not be more than 1. And this is not only the, we can say we have to take a more absolute value and it should not be more than 1, right? So the height of left subtree and right subtree should not be more than 1. If we can divide height left from left minus right and right minus left as well, because we are taking absolute value. So it's not like you can say right part should be always more than 1 in order to get a height velocity, right? So just simple statement, height of left subtree and height of right subtree, the difference between them should not be more than 1. It can be 0, it can be 1, but not more than 1. It should not be 2 or 3, right? So let's see whether our this answer is height balance by necessity or not. So you can see if we talk about root, then left height is nothing but 2, right height is also 2. So we can say the difference between them is nothing but 0, right? So this is a height balance by necessity because it is not more than 1. If we talk about minus 3, the left side we can say the 1 height, right side is 0. So 1 minus 0 is nothing but 1. So still it is a height balance by necessity because it is not more than 1. It is equal to 1, right? So if we talk about 10, it is going to be 0, right? If we talk about 9, the left side is again 1, right side 0. So again it's height balance by necessity and this is nothing but 0, right? So I hope this is making a sense. This is height balance by necessity. Now guys, we have seen the height balance by necessity. We have understood the problem, what we have to do. Now let's see the logic part and let's see this example one, that how they have achieved this particular thing, right? So let's move to the logic part and see how we can solve this particular problem, how we can convert a single linked list to height balance by necessity when we have single linked list in sorted order. Okay, so let me write a logic part. Fine. Now, guys, just forget about this single linked list. In your mind, don't forget, don't think about this is we are given the linked list. Assume that we are given an array. Then how you can solve this particular problem? Are you able to solve this thing? Because array we have just pick up one of we can say insertion part. So can you solve this using an array? Just think about a little bit. Yes, you can solve it. Why not? See, what you all need to do, you need to just find the middle element from your array. If it is your array, nothing, not a linked list, then you just find a middle element, place it over it. Have this making a sense? Then find this on the left side. Always your left side, we can say left of this root is going to be on the left side of your middle element, and right side of your we can say root is going to be right side of this particular middle element. I have this making a sense. Means whatever the right node is going to present, that should always be present in the right side of your middle index, and whatever node you want to insert on the left side of this root is going to present on the left side of your middle element. That is clear, right? So can't we say that the left part, assume that this is nothing but your, this is a linked list, and right part, assume that this is nothing but now this is your linked list, or we can say array, right? I have this making a sense. So now you have maintained a root part. Now it's time to get the left part. So it's left. What should be the left of this particular one? So if you find the middle of these, so always if the number are even, if the nodes are even, or we can say the elements are even inside your array or linked list, you just need to take the next side of it. Like if it is 2, so you are going to take the first. We can say if it is 2, let's say this is a node and this is a node. So total number of nodes are 2. It is even. We can't find a middle element, right? So what you have to do? You have to say divide it by 2. So what you are getting? You are getting nothing but 1. Getting nothing but 1 index. I have this making a sense. So always you need to take this one, right? Minus 3. So minus 3 is there. Now for minus 3, the right part is going to be nothing but we can say, let me write this particular whatever the part after minus 3, right? So there is nothing part. So there is going to be no node. on the right side, but left part is there is some node present on the minus 3 on the left side of minus 3, so that is going to come under the left part. So minus 3, and there is only one part, so it's going to be 10. I have this making a sense. If it is not making, then let me scroll it down and let me write here these things so that you can understand it clearly. So we are having nothing but minus 10 and minus 3, then 0, and after that we are having nothing but 5, then we are having 9. So this is the array which we are having, right? Now assuming that the first time we go to middle this, because they are odd elements, so we got 0, right, middle. So I created a root, so this is nothing but with 0 value. The left side and the right side, right? So left side is going to be nothing but whatever the value presented there. So I can say for left side my array is nothing but minus 10 and minus 3, right? For right side I have nothing but 5 and 9. So I have divided this right side for right node, left side for right node. Okay, now we are going to find just nothing but the middle of minus 10 and minus 3, that is nothing but minus 3. Fine. And if it is we go to middle, then right side and left side is going to be find out, right? So we have to find, so that for minus 3 the left side is going to be minus 10 because there is one element present on the left side, but right side there is no element present, so we're going to say a null, so it is going to return nothing, so it's going to say null. I hope this making a sense. And here is only one node, so I'm going to say middle is minus 10 only, and there is no left side and no right side, so null. So I can say, simply say null, and here write also null. I hope this is making a sense, right? Now in on these sides you can see that the middle of 5 and 9 is nothing but we can say 9, isn't it? And 9 right side is there is no element on the right side of 9, so we can say null. And there's one element on the left side, so it's going to proceed with that particular one, so we can say here is 5 present, so the middle of 5 is nothing but 5 only, so we're going to place 5, and left side is nothing, right side is nothing, so null and null. I hope this is making a sense now, right? So we have to build like this. We have to just find the middle element, and in array it's easily to find. We can just say low plus high, or we can say start index plus end index divided by 2. But we are going to do with using just a linked list only, right? So in linked list also there is a, we can suppose to find a middle element, that is nothing but slow and fast pointer, right? I hope you know this, right? So we're going to use a slow and fast pointer to find a middle element, and then we are going to simply build our height balance by necessity, right? If you still have any kind of doubt, you can ask in the comment section. But now it's time to move to the implementation part, where we are going to implement our logic in C++, Java, and Python programming language. Well, let's move to the implementation part. So I'm here, guys. First of all, I'm with the Python. So what I'm going to do, first of all, I'm going to say, okay, I'm going to say if there's node head, if there's no node, then you have to simply return null. I have this making a sense. So if there is no node present in our linked list, then I have to return a simply we can say null array, null height balance minus system, but right. And if node head dot next, this is base case, right? If there is no node present on the next node, we can say like there's only one node present on our single linked list, then what we are going to say, that is going to be nothing but a root node, right? So we can say tree node, okay, and here we can say head node value. So we have written that particular node, right? But if there are more than one node, then we are going to use our logic. We are going to find the mid value, we are going to place the root there, and left side of root is going to be the left side of mid, and right side of mid is going to be right side of our root, right? So we're going to say let's find a mid value, right? Mid value, mid node. So how we can find, we can say slow is going to be nothing but head, and fast is going to be nothing but our head, and one more pointer previous is nothing but is going to be, let's say, none, right? So why I'm saying previous, let me tell you, just wait a second, let me find the first of all mid, then let me tell you what is the use of previous. So I'm going to say while fast, and fast is not equal to null, and fast dot next not equal to none. I can simply use dot next as well, but okay, not null. Here in Python we don't have null, we have none. So fast is not equal to none, and fast dot next is not equal to none. You have to keep going, and here just you have to do slow is equal to slow dot next, and fast is equal to fast dot next, right? So we are moving fast to 2 points ahead, and slow only 1 point ahead. And before doing that, here we are going to use our previous, that is going to be nothing but previous is going to be slow. Why I'm keeping a maintain of a previous node of slow, I'll let you know. So once we are we can say we find out our slow, we're going to say if previous is not null, if previous is not none, then what you can say, you can say previous dot next none, previous dot next none. And we have done this thing just because to break the chain. I hope you are getting it. So if I little scroll it, so let me give it a space. All right, so why we have done this, let me tell you here. So guys, assuming that here we go to this thing 1 2 3 4 and 5, right? So I found a middle 3, right? So now what I have to break it, I have to break it like 1 and 2 on one side, and 4 and 5 on one side, so that I can pass 1 to we can say left no, left root, and 4 to the right root, right? So I have to break it 1 2 and 4 8. So for breaking I need a previous node so that I can make them to null. So If 3 is my slow, then I should get a node, previous node, so that I can make 2 dot next null. So here I'm saying previous dot next null. That means 2 dot next is going to be null. So it's going to break it. Now whatever the slow node is nothing but my middle. So I can say my node is going to be nothing but tree node of slow dot val. I got a middle root, and this node dot left part is going to be nothing but we can say a head part, right? So I can say okay, I can call it a self dot sorted list to BSC, right? So let me call this particular same function sorted. Let me here I use single t sorted list to BST, and here I'm going to pass a head side, right? And I am to pass row dot right, and here is going to be self dot sorted list to BST, and here what I'm going to do, I'm going to pass slow dot next. I have this making a sense, right? Slow dot next is nothing but 4. Okay, and I can make it slow dot next null as well. So all right, so this is going to be done, and once we are done this thing, we are going to return a node, right? And let's try to run this code and see whether it's working fine or not. And you can see that both the test cases are passed, right? So let's try to submit this particular code. And here we go, guys, right? We have successfully submitted our code in Python programming language. And I hope you understood the Python code. Now let's move to the next programming language, that is nothing but we can say C++. Fine. So first thing what we have to check it, we have to check if head is null. So we can say if head is null, so we have to simply return null. Not C, in C++ we have to use a capital letter or null ptr. So I can say null ptr. So we can return null ptr, or we can simply return head. I'm just making a sense, right? But if head dot next is we can say head dot next is exist, right? If it is head dot next is null ptr, means there is only one node, then what I can do, I can say return new tree node, and here I can pass head dot value. Fine. So this was the base case, so let me give it some space here. All right, so this was a base case. Fine. Now what we are going to do, we are going to say list node slow, which is nothing but we can say head, and then one more thing which is going to be nothing but fast, right, which is going to be again head, and last thing that is previous, which is initially a none. All right, so we made this particular things. Now once we have done these things, we are going to check use a, you can say middle element. We are going to find a middle, so we can say while fast is not equal to none, and we can say fast next is not equal to null ptr. So you have to keep move, you have to say slow is equal to slow dot slow next, and fast is going to be fast next and next. I have this is making a sense, right? Before doing a slow next, I have to store in previous. So previous is going to be nothing but slow. And here I can say if previous is equal to null ptr. So what I can say, I have don't have to do anything. But if it is not, if previous is not equal to null ptr, then we can say previous next should be equal to null ptr. And we have break the chain. Now we are going to call sorted. So we can say we are going to create first of all a node. So I'm going to say list node. My node is going to be nothing but we can say new tree node, and here it's going to be slow dot val, node dot slow of val. And once this is done, we are going to say node dot left part, node left side should going to be same function sorted list to pst, and here I'm going to pass left side, so I can pass head only. And same thing I'm going to copy and I'm going to do for right side, but here I'm going to pass my slow dot next, slow next, right? So once this is done, I'm going to return node. I have this is making a sense. What I am doing, I'm first of all checking whether base conditions. After that, I'm finding the middle element, that is nothing but slow element. So I'm going to make a node with a middle element, that is going to be my root node. The left side is going to be nothing but node left side is going to be nothing but we can say the I'm going to pass the left linked list, that is pointing to head. Right side I'm going to pass slow dot next, which is pointing to right part of my middle element, right? So I'm going to run the code. So here I got an error, I can't return head. So okay, so it's saying that you can't return a head, so you can return simply null ptr. Let's try to run this code. So okay, the one thing is not null. In C++ we don't have null, we have null ptr. All right, so null ptr, and we also have null also. All right, so the last thing which we are having is nothing but node, right? So it's saying that list node, okay, cannot say variable list node with the value of these things. So fine, so we are getting error over here. It's saying that cannot initialize a variable of type list node with a R value of type nodes. All right, so what else I can do, I can see here. So I can say, okay, this is gonna be new tree node slow dot well, right? So let's try to run this code again. All right, so let me see what else I could do. Okay, so I'm using a list node, I'm doing a tree node, right? So that was the issue, isn't it? So we just need to use a tree node here. I hope this making a sense. That was a silly mistake, isn't it? All right, so let's try to run this code. Now you can see that both the test cases are passed. And let's try to submit this code. Hopefully, don't think I should get any error. So let's see. And you can see that we have successfully submitted the C++ code as well, isn't it? So now let's move to the next programming language, that is nothing but Java. And this is a last programming language. And I don't want to get any error in this programming language because it is a hard one. So if head is equal to null, so we can simply return. Okay, so we can simply return null. And if head next is not dot, we have to use dot. If head next is equal to null, so we are going to simply return new, we can say a tree node of head, and we can write a value, right? So once we have done this thing, we have seen the base condition. Now it's time to find the middle element. So what I can say, I can initialize some variables. So I can say list node is going to be slope, which is going to be nothing but pointing to head. One more is going to be node, we don't have a pointer in Java, so we can say slow. List node slow is going to be nothing but pointing to our head, and fast is also pointing to head, and previous is pointing to null. Okay, so we can write here null, right? So once this is done, what we are going to do, we are going to say while fast is not equal to null, and fast next is not equal to null. Then what we can do, we can say keep moving and find the middle element. So we can say slow should be equal to slow, let me write a slow dot next. So what is this? Slow dot next, and fast is equal to fast dot next. And here one more ahead steps for it because this is fast pointers, and here we're going to say previous is equal to slow. So we're storing the slow element as well, right? So once this is done, we are going to say if first of all, let's create a tree node, which is going to be nothing but we can say node pointer. So tree node is going to be nothing but we can say a root node, and here we can say new tree node, and here we can pass our slow dot value, right? So slow dot when. Once this is done, we are going to make a previous dot next is null. Okay, so we have break the chain, so we can say previous dot next is going to be null. So once this is also done, so what we are going to do, we are going to, let me scroll it down. So what we are going to do, we are going to say this node dot left side is going to be nothing but, let's call the same function sorted list to bst, and here I'm going to pass head, and this right side node dot right side is going to be sorted list to bst, and here I'm going to pass my slow dot next. After that, what I'm going to do, I'm going to return simply node. So let's see whether we are getting any error or not. So let's try to run this code. And I have to check one more condition here. If tvs is not equal to null, right? If it is not equal to null, then only you have to make it previous next is null. I have this making a sense, right? So again, let's try to run this code. All right, so now let's try to submit this particular code. And here we go, guys, right? We have successfully submitted our code in Java as well, and you can see that the beat 100%, right? So I hope, guys, you understood this particular logic part, implementation parts. And if you still have any kind of doubt, you can ask in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.